In lesson 10.6, we're going to be talking about the volume of a sphere. And the volume of a sphere is a very particular formula, one that you'll have to memorize, of course. And it is 4/3 times pi r cubed. I'm going to write it a little bit bigger because that print's kind of small. So the volume of a sphere is 4/3 times pi times the radius cubed. And so down below, we see a sphere with a radius of 5. And all we do is we take that 5, we plug it in for the radius, and we're finished. And so you can see that here in the formula that's written out. So you just type in your calculator 4 divided by 3 times pi times 5 to the 3rd power. And in your final answer, you will come up with 523.6. Don't forget volumes in cubic units, so inches cubed. And basically, it's just the memorizing of the formula. This will show up on your MCA tests, on your PSATs, ACTs, SATs, 4/3 pi times r cubed, r being the radius. Once you know the radius of the sphere, it's game over. Let's apply some of this stuff. Let's go to an in-depth problem here. Down below on the left side, we see a picture. And we have a cube. It's a plaster cube, and it has a side length of 16 centimeters. So this side length of 16 centimeters means right here that I have a 16 on the edges of the cube. And what we want to do is we want to figure out the percentage of plaster that would have to be carved away. That means the garbage to generate the largest possible sphere. And to find that, we need the volume of the sphere and the volume of the cube. So, as we look at this, the volume of the cube, since we have an edge length of 16, is just 16 times 16 times 16, or in other words, 16 cubed. So here's the volume of my cube, 4,096. And that was taken by getting the 16 times the 16 times the 16, or in other words, the area of the base times the height. Now we also have to find the volume of the sphere. I know that if I'm trying to find the volume of the sphere, if my edge length of my cube is 16, that means my radius had to be 8 to go to the side. So now if I want to find the volume of that sphere, what I do is I take 4/3 times pi times 8 and cube the 8, 4/3 pi r cubed, and what I find is that the volume of my sphere is 2,144 when I do that formula. Now, when we compare those two volumes, what we see is that if we're going to figure out what's going on about how much was chipped away, what I'm going to do first of all is I'm going to find out, since I have my volume of my cube and I have my volume of my sphere, I'm going to subtract those two because that equals the chipped away part. Because take the cube, have left the sphere, and that's how much is gone. When I do that, what I see is I take my 4,096 and I subtract off my 2,144, and that means that my chipped away part was 1951. So this is how much plaster I had to waste in order to get my sphere. If you want to know what percentage that is out of how much you started with, you divide that by the original amount that was there, which was the cube. So I divide that by 4,096, and what I find out is, as a decimal, I get 4764, which we know that if you move the decimal 2 places, you get 47.64%. This percentage is the percentage of plaster that was chipped away to create that perfect sphere. In this last problem in this lesson, what we're going to do is we're going to find out the volume of what's left over when we scoop out something out of a hemisphere. So down below here, we see a hemisphere. The bigger hemisphere has a 5-inch radius, and the smaller one has a 2-inch radius. And imagine, if you will, an avocado that's sliced open halfway, and you want to take the pit out. And what you want to know is how much volume is left over after you take the pit out. And so what you do is you find the volume of the bigger hemisphere, subtract the volume of the smaller hemisphere, and that's your answer. Now, earlier we learned that the volume of a hemisphere is 4/3 pi r cubed. So half of the 4 would be 2, or in other words, the volume of a hemisphere would be 2/3 pi r cubed, which kind of common sense kind of clicks, I guess, for me. So I'm going from a 4 into a 2, because 2 is half of the 4. So that's a hemisphere. So let me write that again. The volume of a hemisphere is 2/3 pi r cubed. And so what I know is I have two different hemispheres here. I have the outer hemisphere, and if I look at the outer hemisphere, that's the one with the 5-inch radius here. To find its volume, I go 2/3 pi r cubed. Its radius is 5. So when I know that its radius is 5, which we can see right here, the 5 for the radius of the outer hemisphere, I get 261.79. If I look at the inner hemisphere and use the formula 2/3 pi r cubed, that's this inner hemisphere, and its radius is 2, which we can see here. So I find the volume of that hemisphere, 2/3 times pi times 2 cubed, and we get a volume that is 16.75. And what we're going to do is we are going to subtract those two numbers. So we subtract those two numbers off, and when we subtract those two numbers off, we get a result of 245.04. So again, we take the volume of the outer hemisphere, which was 261, we subtract off the volume of the inner hemisphere, which was 1675, and we get our end result. Kind of the main idea here was finding the differences, and the fact that if a sphere has a volume of 4/3 pi r cubed, then a hemisphere has a volume of 2/3 pi r cubed.